Whenever we talk about AI, the conversation always seems to get stuck on this idea of perfection versus failure. But what if that's the wrong way to look at it entirely? In this explainer, we're going to dive into a totally different perspective. The real question isn't about whether AI will ever be flawless, but how we can build smarter teams by understanding its specific and sometimes really predictable imperfections.
Okay, so let's set the stage. From airport security to police investigations, machine learning is being used in some incredibly high-stakes situations. We're talking about decisions that can literally change the course of a person's life. This isn't some far-off sci-fi concept anymore. It's happening every single day. And when these systems get it wrong, the consequences can be absolutely devastating. And look, this isn't just a theoretical risk. Back in 2020, Robert Julian Borshak Williams was arrested, wrongfully, right in front of his family, all because a facial recognition system made a false match. His was the first documented case like this in the US, and believe me, it hasn't been the last. This story really brings home the problem we're digging into today.
So, that brings us to the big question, right? It's the one at the very heart of the research we're breaking down here. When the cost of a mistake is someone's freedom, how in the world do you use this technology safely? It's not about banning it, but about building systems you can actually trust. How do we create a process where a human expert can watch over an algorithm to stop these kinds of catastrophic errors before they happen?
To answer that, researchers decided to do something different. They stopped just pitting humans against machines to see who's better. Instead, they started studying how they could work together. The key idea here is something called complementarity, which is just a fancy way of saying that humans and AI don't just have different strengths, they have fundamentally different weaknesses. They mess up in completely different ways.
To really get this, we've got to be super clear on the two main ways things can go wrong. First, you have a false positive. That's when the AI screams, it's a match, but it's actually two totally different people. That's the wrongful arrest case right there. Then there's a false negative. That's the opposite. The AI says, nope, not a match, when it's actually the exact same person. Seriously, getting the difference between these two is the key to unlocking this whole thing. So, the researchers set up this awesome head-to-head comparison. They took two state-of-the-art facial recognition AIs and put them up against a group of 162 human reviewers from all sorts of backgrounds. The task couldn't have been simpler. Look at two photos side by side and just decide, are these pictures of the same person? Yes or no? And what they found was, well, it was pretty fascinating. By really digging into the mistakes that both the humans and the machines made, they uncovered three key findings that show just how differently our minds and their circuits get things wrong.
All right, now this is where it gets really interesting. When the researchers looked at how humans did on pairs of different people, a wild pattern emerged. We are incredibly good at telling strangers apart. In fact, we only made that dangerous false positive error less than 5% of the time. But when we were shown two pictures of the same person, our error rate shot up to around 30%. We're much more likely to say, nope, not a match, when it actually is. So this leads us to the first huge takeaway. In this kind of task, humans have a genuine superpower. We are exceptionally good at avoiding the most dangerous type of error, the one that accuses an innocent person. This is a strength we can build an entire system around.
But what about the AI? Does it have a tell? Does it give away clues when it's about to mess up? Oh, absolutely. When the AI looks at a pair of faces, it spits out a similarity score. A score of 1 means definitely a match, and 0 means definitely not a match. And it turns out the vast majority of the machine's mistakes happen right in the middle, around a score of 0.5. This is its zone of low confidence. It's like the AI is raising a little yellow flag saying, hey, I'm really not sure about this one.
And that right there is our second key finding. The AI's mistakes aren't totally random. They often come with this built-in warning sign. When the algorithm is on the fence, that's when it's most likely to be wrong. And that is a critical weakness we can totally exploit.
The third finding, though, that's where things get a little tricky. You see, for those really tough false negative cases, failing to match two photos of the same person, it turns out both humans and AI are kind of bad at it. If two different AI models both make the same mistake on a pair of photos, humans are also much more likely to get it wrong. It's like a shared blind spot.
Okay, so let's just quickly recap. We know humans are great at spotting false positives. We know the AI basically tells us when it's feeling uncertain. And we know they both struggle with the same tough false negatives. With all this knowledge, we can finally stop just analyzing the problem and start designing a really powerful solution. And the strategy that comes out of this is it's so simple and elegant. Here's how it works. First, you let the AI do all the heavy lifting, blazing through thousands of image pairs. But you tell it to flag two very specific things: any case where its confidence score is low, and any case where two different AI models can't agree on the answer. Then, and only then, do you bring in the human experts to look at just that small, targeted batch of really tough cases. So, the million-dollar question: does it actually work? Oh yeah, the results are incredible. This new strategy gives you this massive boost in accuracy for a tiny amount of human effort. It's way, way more efficient than just having humans randomly check the AI's work. It's about being smart and targeted. Let's put some real numbers on that, because this is pretty cool. The AI working by itself had an accuracy of 93.5%. Not bad, but definitely not good enough for these kinds of decisions. But by using this smart review strategy, having humans check just 10% of the trickiest cases, the overall accuracy jumped a full 3 percentage points, up to 96.5%. Now, that might not sound like a huge number, but it means they corrected 148 wrongly classified pairs. That's 148 potential mistakes averted with minimal human effort. That's huge. And, this is about so much more than just facial recognition. This whole approach gives us a blueprint for how to think about teaming up with AI in any field where the cost of an error is just too high. It's about designing a better process, not just chasing a better algorithm. And that brings us to a really important point that kind of flips the whole conversation on its head. This race to build a perfect, all-knowing AI that can just replace human judgment, it might not just be unrealistic, it might be completely the wrong goal in the first place. Instead, the real takeaway is this: we should be focusing on designing intelligent systems where we treat human expertise like the valuable, limited resource it is. It's about creating partnerships that use our unique strengths to surgically correct the AI's very specific weaknesses. What you end up with is a team that's safer, more accurate, and way more trustworthy than either a human or a machine could ever be on their own. And that leaves us with one final thought to chew on. If the goal isn't the perfect AI, but the perfect human-AI team, where else do we desperately need this kind of thinking? In a hospital, for medical diagnoses? In the justice system? In financial auditing? This strategy for smart, targeted oversight, this might just be the key to unlocking the true potential of AI, safely.